Hi everybody, this video is going to be about how to convert back and forth between mass and moles. And remember that the unit that we're usually using for mass is grams. So really it's about how to go back and forth between grams and moles. So G and MOL as a unit. All right, the way we're going to do this is to use molar mass. So molar mass is a way that we can measure the weight of a mole, and its units are always going to be in grams per mole. So some examples are that oxygen gas O2, if we look on the periodic table, we would see that oxygen weighs 16.00 grams, and since there's two of them, two atoms, we've got to multiply by 2. We always multiply the number from the periodic table by the subscript, and we get the total mass of oxygen gas, which is O2, is 32.00 grams per mole. MOL. I can't write that right now. I'll write it sideways. Grams per mole. All right, so that means that in 32 grams of oxygen, there's a mole of oxygen molecules. So a mole is the way that chemists count numbers, or count atoms and molecules. All right, so the first kind of problem that we're going to do here is a mole to mass calculation. And that's shown by the example here. Always when you're doing these kind of problems, we're going to use dimensional analysis, and we're going to underline our starting unit, which is 3.5 moles, and we're going to underline our ending unit, which is grams. So we have our starting amount, we have our ending unit. We always put our starting amount over 1 in the calculation, so we do 3.5 moles over 1, right, like that. All right, and then we have to use the molar mass to go here, except this is the molar mass of water. It's not oxygen this time, so it's not going to be 32 we're going to use. We have to figure out the molar mass for each chemical. And so the way we're going to do that is we're going to look up the atoms on the periodic table. We're going to look up hydrogen on the periodic table. It's 1.01 is the mass of hydrogen on the periodic table. And we multiply that by 2 because there are 2 hydrogen atoms. And then every time we switch an atom, we add. We switch elements, we add. We put a plus there. And we look up oxygen is 16.00 on the periodic table. And when you add that all up, that's 18.02 grams per mole. Well, so that's what we're going to use as the conversion factor. We're going to use molar mass as the conversion factor that goes as your next fraction here. Now notice the grams per mole, that slash there is actually a fraction bar, is a conversion factor. And so what we're going to do is we're going to need to put 18.02 grams on one side of this fraction down here, and the 1 mole, because it's grams per mole, it's per 1 mole on the other side. And so we're going to put the 1 mole in the denominator and the 18.02 grams in the numerator. The reason we do that is because moles cancels moles. Remember, this is all one big fraction bar, and so we're going to multiply across the top, multiply across the bottom, and then divide. And so when we do 3.5 times 18, we get 63.07 grams, right? The moles cancel, so we don't put moles. And I'm going to round that to match the original number. So it's just 63 grams. So our conclusion there is that 63 grams of water are in 3.5 moles of water. Or in other words, if you have 63 grams of water in the lab or you're drinking it, you know how many moles you're drinking. That sounds kind of gory, but yeah, you're drinking moles every time you drink water. All right, the other kind of problem we're going to do is a mass to mole problem. All right, so this is going the other way. Instead of going moles to mass, we're going mass to moles here. And so we're always going to do every dimensional analysis problem the same. We're going to underline the starting amount in unit, so 100 grams. And we're going to underline the unit that we're being asked to find. In this case, how many moles? We're going to underline moles. We're always going to put our starting amount over 1, so 100.0 grams goes over 1. And we're going to multiply it by conversion factor. And this time, the chemical is carbon dioxide. So we got to look up carbon on the periodic table. It's 12.01. And then we have to add oxygen, which is 16.00. And oxygen gets multiplied by 2. Make sure not to multiply the 12 by 2. It's just the 16 times 2. And so when we do that all out, we get 44.01 grams per mole. That's the molar mass of carbon dioxide. And so we got to use that to get between grams and moles. We're going to put this in the fraction. This time, though, grams is in the numerator here. So grams has to go in the denominator in the conversion factor so that it cancels. So remember, anything in the numerator can cancel anything in the denominator. Grams cancels grams. Well, in the numerator now is the mole part, 1 mole. because this is the molar mass. It's the mass per mole. So we have 100 divided by 44.01. We multiply across the top, we multiply across the bottom, we divide. I get 2.272, and the unit that's left is moles, so that's the unit of my answer. And so it makes sense that if 1 mole is 44.01 grams, then 100 grams is about 2 moles. That makes sense.